Okay, this is the video for exercise 5C in statistics 1, using formulae to solve problems. So we can start with the problem and then look at the formula. So I'm going to have two events, A and B, represented by a Venn diagram. Okay, probability of A is going to be 0.4. So move that to there. And then probability of B is going to be 0.7. Just move that up. Now we can't fill that into the Venn diagram because we don't know if there's an intersection or what that intersection is. Okay. So our intersection is going to be 0.2. And our probability of A union B is something I want to find. Okay. So let's have a look what we've got here then. Let's start with the probability of A union B being A and B both combined. So I'd have probability of A be 0.4, probability of B is 0.7. Alright? So now if I added both those things together, I'd be adding the intersection twice. So this value would be added on twice. Alright? So 0.4 plus 0.7, that's taking the intersection into account twice. So if I take away 0.2, I'll get my answer for the probability of A union B, which will be 0.9. So let's see if we can generalize that now then using algebra. So rather than just using numbers, we can come up with the general rule for finding the intersection or the union in a probability problem. Okay, so in this problem, I'll let probability of A equal A, probability of B equal B, and the probability of A intersection B equal X. Okay, let's fill that into the Venn diagram now. So X goes in the little rugby ball shape on the intersection. So all of A is equal to A. So that little bit is going to be A minus X. Similarly, probability of B, so that entire circle is represented by lowercase b. So that little crescent shape is B minus X. Okay? And then just to complete the Venn diagram, if we add all of this together, we have A plus B minus X plus X, so that would cancel, leaving us with just this subtract X. So our outside of the circles, to fill in the rest of the box, would be 1 minus brackets A plus B minus X. So that's everything filled in. Alright? So now, I want to get an expression for the union of those sets. So the probability of A union B would be those three sections added together. So A minus X plus B minus X. And if we tidy all that up, that's going to give us, well, these minus X plus X would cancel. So it leaves us with A plus B minus X. Okay? And then, if we replace those A's, B's and X's with probability of A, probability of B, probability of A intersection B, it leads us to this formula. Okay? Which is a really useful formula in statistics. Particularly if we rearrange it and swap the probability of A union B and the probability of A intersection B around. It's a good way of being able to work out the intersection. What we tend to use this for is to work out the intersection from a problem using this formula. Then we can fill in our Venn diagram, and then it's like exercise 5B. Okay, so these are two really important formulas for you to memorize and learn and remember, and they're called the addition formulae in statistics. Okay, if you know where they come from and understood that proof, it'll make it easier for you to understand it. So this next example is a good example to show how we can use that formula to solve a problem. Alright, so we're told A and B are two events, probability of A is 0.4, probability of B is 0.5, and the union is 0.6. All right, and we're going to use it to calculate a few probabilities after we've done the sketch of the Venn diagram. So we've got our entire set. So a circle to represent A, a circle to represent B. Okay. Now we can't fill in anything at the moment because we know what that circle is represented by 0.4. We know 0.5 represents that circle there, and we know the union, all the things to combined, is 0.6. Okay. So probability of A intersection B is equal to probability of A plus the probability of B minus the probability of A union B. So if we just fill those numbers in from above, so we'll have 0.4 plus 0.5 minus 0.6. That's going to be equal to 0.3. So now we've got enough information to fill in our Venn diagram. So our intersection is 0.3. So A is 0.4. So we know that little crescent shape there is going to be 0.1 because 0.1 plus 0.3 adds up to the 0.4. And then the other crescent shape with B, okay, we know that circle B is going to have to add up to 0.5. So this little section here is going to have to add together the 0.3 to get 0.5. So it's going to be 0.2. And don't forget to finish off outside of the circles. So we've got the entire set. Remember, these are probabilities we're dealing with. So they're all going to have to add up to 1. So 0.1 plus 0.3 plus 0.2 is 0.6. So we've got 0.4 on the outside to finish off the Venn diagram. Okay, done. So now all the probabilities we can work out are going to be nice and straightforward using the Venn diagram, just like we were doing in exercise 5b. So probability of the complement of A, remember that's the probability of everything that's not in A. So if we go to our Venn diagram, that's just going to be everything outside of that circle. So it will be the 0.2 plus the 0.4. So our answer is just 0.6. Okay. Just put the work in there for you. Alright. Ooh, what's going on there? Right, let's stick it up to there. Right. What should we work out next? Probability of A union B complement. It's a little bit more complicated. So that's going to be everything that's in A and everything that's not in B combined. Alright. So using that shading skill, diagonally shade A, and in the opposite direction shade the complement of B. And now because we're looking for the union of those two things, it's going to be all the areas that are shaded, including the crosshatch and just the other normal shading. So basically it's everything outside of this crescent. So it will be 0.4 plus the 0.1 and 0.3 in there. Okay, so our answer is just going to be 0.8. Okay, just show all that working out. And then if we move that again, I think we're going to do one more. What should we do next? Probability of A complement union B. So just do the other way around. So again, quick sketch representing the original Venn diagram. So diagonal shading in the one direction to represent the complement of A, and then the other direction to represent B, and because it's the union this time, we're looking at everything that's shaded. Alright, so everything apart from that little crescent shape, so it's going to be the outside, the 0.3, 0.2, everything apart from that 0.1 I was just pointing at. So if you add all that together, it's just 0.9. Okay, dead simple. So your method needs to be, you have to sketch the Venn diagram, you've got no other option. Okay, use your formula then to work out the intersection or the union, and then use that sketching idea as well, so that you can locate the regions where your probability is going to come from. Okay, right, good luck.